Hello everybody, this is Miss Pi and I'm recording this video to help my students with the transformation paperwork for their semester project. And as you can see, the formulas in this column are just different formulas that I use to graph my eagle um, that I was showing shortcuts and simple steps on how to graph your pictures. Okay, so um, after another thing that you have to do for your semester project is fill out this paperwork, and it consists of doing the transformations for your absolute value function, power function, square root, rational, exponential, logarithm, and linear functions. And I'm just going to go through each one, and I've already circled the things that apply, and I'll write the numbers as I go through. So in this case, your absolute value function, this number right here, the negative 1.5, that's your A value, and that's going to stretch it vertically by a factor of 1.5. Notice I'm not including the negative here because the negative is causing it to reflect vertically. It's going to, your absolute value function normally opens up like that. Well, because of the negative, it's going to open down like that. Okay, let's keep on going. So now this number here, the 0.65, is going to shift it left or right because you have a minus sign right there. It's going to shift it to the right, and then right in this space we just put down how far it's going to shift. So it's going to go to the right 0.65 units, and then this negative 2.6 at the very end of the equation is going to cause it to go down. So it goes down 2.6 units. So here is where you're circling either vertical stretching or vertical compression, horizontal stretch or compressing, reflecting horizontally or reflecting vertically, shifting it left or right, and shifting it up or down. Okay, so those you would circle, and then in the blank boxes, if you circled something up here in the blank boxes, you need to write down how much of a stretch or compress or shifting. Okay, and a couple things I wanted to point out. Let me go ahead and erase some of this. I want to point something out with the example 1 and example 5. So anytime you have where you're multiplying the function type, notice your absolute value symbols are here, so that's your function type, your parent function. Anytime you're multiplying the function type by some number, that's going to be a vertical stretching or compressing. But anytime you multiply the x value itself by some number, that's when you're going to have horizontal stretching, compressing, or reflecting. Okay. Let me get rid of those lines, and then we'll move on to our power functions. Now, some of my students have forgotten that your quadratic formula falls under your power function. You could also have a cubic function where you have x raised to the third power, or any number where you have x raised to any value, 3 raised to the third power, the fourth power, whatever. Those are all power functions. So it doesn't have to be x squared. It could be x to the third or x to the fourth. Okay. Let me undo those. All right. So then let's go ahead and figure out all the transformations for this equation. Again, we have a vertical reflection because of the negative sign, and then this time we're compressing because our value is less than 1. So because of the decimal 0.88, that's a compression of a factor of 0.88. And then we're not doing any type of horizontal stretching or compressing. You don't have to cross these out, but you can if you want to. It's totally up to you. And then we are also shifting it to the right because of the negative sign right here. It's going to the right by 0.96 units. And then it's going up 1.15 because of that plus 1.15 at the very end. That tells us that our graph is shifting up. Okay, for the square root function, we have a vertical compression by 0.5. Okay, and then it's reflecting horizontally because of the negative here. And then it's also shifting to the right by 4 units, and it's shifting up by 1 unit. Okay. This rational function, notice my 1 here. Because I have a 1 here, then I don't have any type of vertical stretching or compressing. If that 1, let's say that 1 was a 2, then it would stretch by 2. But if the 1 was up there, and then in the denominator I had this in parentheses, and let's say I had a 2 here, what that would actually be would be a vertical compression by 1/2 or 0.5, either one. Okay, so be very careful with your vertical stretching or compressing with your rational functions. If you have a number in the denominator that you're multiplying this by, then it would be 1 over 2, or like if you had a 3 there or whatever, it would be 1 over 3. Okay, so let me undo that because that wasn't part of the original. All right, so now this one, this example here does not have any vertical or horizontal stretching or compressing. Doesn't have any reflection either. It just has a shifting to the left by 1.5. And the reason why I know it goes to the left is because of my plus sign here. You know, notice here, here, and here, it was all minus signs and it was going to the right. Well, when it's a plus sign, you're going to the left. Okay, and it's by 1.5 units, and then it's also going down 4 units. And then this exponential function, exponential functions can be a little bit tricky on the vertical stretching or compressing. Okay, so for the exponential function, just do not worry about the stretching or compressing vertically or horizontally, mainly because it's this number right here that determines that type of stretching or compressing. And there's really not just one basic standard parent function number there. Frequently people will start off with a 2, but that's not necessarily a parent function or the parent value. So don't worry about stretching or compressing for the exponential function. Just focus on reflecting or moving up or down, left or right. So in this case, it's going to the left by 4.25 units. And it's not going up or down at all. But let's say you wanted to move it down, then way out here, outside of this parentheses, outside of the exponential, that's where you would put, let's say you want it to move down 3 units, so you'd have a -3, or if you wanted to move it up 3 units, it would be a +3, okay, if you wanted to shift it up or down. All right, moving on, your natural log function. Again, don't worry about vertically stretching and compressing, and natural log, remember that's one of the ones that you can click and drag, and so that's the only reason why I have this value. I normally would never have come up with that one. Now, horizontal stretching and compressing, because I'm multiplying directly the x directly by some number, that's going to be a horizontal stretching or compressing, and if it's a number less than 1, it's going to be a stretch. If it was greater than 1, it would be a compression. Okay, horizontal stretching and compressing is the opposite of vertical stretching and compressing. Don't forget that. Okay, and then this is going to the right, 0.79 units. Ugh, I need to get rid of that. Okay, 0.79 units. Okay, and it's not going up or down at all. Again, you don't have to cross these out, but you can if you want to. Now the last example I'm going to look at or show you is the linear function. And with the linear function, you just need to tell me what the slope is and where the y-intercept is. And that it should be super easy. We're multiplying the x by -0.7, so my slope is just -0.7. And the y-intercept is at -0.051 because that's where your intercept is. Okay, and that's the linear equations are super easy. All right, so hopefully this has helped you with filling out your own transformations. Notice here I did not include any of the limits on my formulas. I just did the equations themselves. you do not have to include the limits. All right. Hopefully this has helped you.